Okay. I don't want to. How should I say this? I I don't want you for a second to think that this is a proof. Okay. This is not a proof. In fact, Euclid, one of the greatest math minds in history, the father of geometry as we know it, even when he put forth his book called Elements, which is still being used today, the most copied book in the entire world other than the Bible. But Elements would be second on that list by Euclid. And that book, even as it became more publicized in a later age, mathematicians started to revise it a little bit and say, well, yeah, Euclid did a nice job with this, but he should have gone further with his proof. Okay? So I want you to understand that this is not a proof, especially for you, YouTube Nation, but this is to help you understand the reasoning behind what we're doing. Okay? So this will help you understand. So this is a brief reasoning, not a proof. If you'd like to see a proof, go ahead, check out your book, chapter 5.3, and you'll see it. But if you do want to begin to appreciate the mind of a math person and a math major, you do need, someday you'll need to really appreciate and love proofs, because there comes that time where that's all you're doing in your math classes. So if you want to go down that road, it's a great road for some. So anyway, all right, we have this area right here. We're going to call that 0. We are going to call this x, and we're going to call this x plus h. Okay, so if I do that, what is this width right here? It is h. You guys remember that from a long time ago. So I'm going to make a couple statements, and you're gonna not like this notation right away, but trust me, you're gonna like this better than the notation I could use. So I'm just gonna say this: the area bounded from x plus h to x. That stuff I just marked up over there. Okay, can you just accept that this is notation for area right now? That we're going to use that. Everybody okay with that? Okay. Then what I want to do is I want to write an expression for what that's actually equal to. And I'm going to say that that area is equal to the area from 0 to x plus h minus the area from 0 to x. Would all agree that that's reasonable? Do you understand what I did? They're not exponents. It's like a superscript. Okay. Yeah, like something you would use in chemistry. So this is, the area from x to h to x, so this blue area. If I wanted to get that blue area, one thing I could do is take this red area, which is from 0 to x plus h, and I could subtract off the green area, and that would leave me with the blue area. Okay, so that's what I'm doing. Okay. All right, so what I'm going to do now is I'm going to write an expression using that. I'm going to say that the area I'm going to say that that specific area, which is the blue stuff, I'm going to set some boundaries for it, okay? Okay. I'm going to set some boundaries for it. It's very important you understand this process, okay? And it very well may be confusing, but we'll be okay. This area right here, it's not a perfect rectangle, is it? Okay, so I'm just going to make one rectangle, and I'm going to make a rectangle that's going to underestimate the area. What's the height of that rectangle? Y, which is f of x. So the area of that rectangle, which would be the width, what's the width? H, what's the height? F of x. So would you agree that that's a slight underestimation? Okay, so h times f of x. Let's do the other side. Would you agree that that's an overestimation? What's the width? H, what's the height? F of x plus h. So we have h times f of x plus h. That's kind of interesting. I've got an h on both sides. I don't have one in the middle, do I? I want to put one in the middle, and you'll see why here in a little bit. This really ends up working out quite amazing. We divide by h. Everything by h. And I get f of x. If you have a phone out right now, you probably want to put that away because you won't understand what's going on. Less than area from 0 to x plus h minus area from 0 to x all over h is going to be less than f of x plus h. Nope. Guys, again, this is not a proof. Okay, this is a general just reasoning. As Nathan said, it's not always going to be like that. He said what you could do is, you could have a situation where f of x plus h would be less than f of x. I could switch it around. But what will always be the same is what happens in this step, and that will make them equal. So it doesn't matter that we could switch it. What we do now is absolutely amazing. Any idea what we want to do with h? Think back to way at the beginning of the year. Oh, yes. Nathan got it. Make it approach 0, dog. All right, let's think about this. Okay, we're going to do that. We're going to make h approach 0. Watch what happens. Yeah. No, we could switch h. We can move h around. So watch what happens here. If I move h to 0, would everyone agree that f of x would then approach f of x plus h? That those would be about the same. That if I bring h if I bring h to 0, that will slide this point very close to x. And those two outputs are going to be almost identical, right? Those two outputs will be almost identical. Watch. If we let h go to 0, then this is the last state of reason you guys have to think through. If I let h go to 0, you guys told me that the height of this spot will eventually be the height of that spot. You're okay with that, right? Well, if this and this are going to be the same, what has to be true about the middle? That has to be the same as well. We're squeezing it together. This is actually called the sandwich theorem. It's something in calculus we didn't cover. It's a nice proof, but we're going to sandwich it all together. They're going to be the same. So what you could say is f of x is equal to the limit as h approaches 0 of area from 0 to x plus h minus area from 0 to x all over h. Oh my goodness gracious. Do you see it? Do you see it now? Okay. Let me show you. Okay. Watch. Okay. This is super important. This is the whole idea. This is the whole idea. So this is what you have to get in your head. You hopefully recognize that there is a connection here. Okay. But the important thing you recognize now at this point is the following. If I want to take the derivative of f of x, I stick it into this. If I want to take the derivative of f of x, I use this piece right here, right? And I come out with f prime of x. Everybody good with that? So we'll use that same reasoning. Shh, boys and girls, quiet. I'm talking. If you take the derivative of the area function, which is this, you will get that. Watch this. So we'll go opposite now. Watch this. If you want to find an antiderivative, so we're going to go the other way. For example, what do you take the derivative of to get cosine? Sine. Yeah. So this says cosine, the antiderivative is sine. Watch. The antiderivative of f of x is the area function. That's because we haven't talked about it before. It's right now. And you got it though, right? It's the antiderivative is what you take to get the derivative. So the antiderivative of cosine is sine. You take the derivative of sine to get cosine. Question. You could go backwards. Yeah. Yeah. So you guys, here's what you need to learn from this. Before, we've been used to taking the derivative. You take the derivative of f of x in order to find slope, f prime of x. What you're learning now is in order to find area, you take the antiderivative, and that will give you area. So derivative gives you slope. Antiderivative gives you area, and it's just that simple. The area function is the antiderivative of f of x. Yeah. Antiderivative does not mean that you hate the derivative. Okay? Here's the fundamental theorem of calculus, part 1. Suppose that the area function is equal to what we just learned from the statement above is if you take the derivative of the area function, you get the actual function. If you want the area, you take the antiderivative of the previous function. Now, first let's define what an antiderivative is. We will work through it, and then we'll do just a basic problem. Okay? Antiderivative for f of x equals x to the n. Suppose that you wanted to find f prime of x. Well, given f of x is equal to x to the n, then you know f prime of x is equal to n times x to the n minus 1. You guys are all used to that, right? Well, we go the opposite way. So to find an antiderivative, and in this case, we'll say that the antiderivative of f of x, instead of writing prime, what we do is we write an uppercase f. We increase the exponent by 1, and we divide it by the exponent plus 1. And that's where we're at. No. Okay, so that's the rule for an antiderivative. Let's try finding a few antiderivatives. If f of x is equal to x to the third, then f of x is equal to... Boys, you're talking as though you already know the material, which is far from the truth, okay? F of x is equal to, if f of x is x to the third, what's capital F of x going to be then? X to the fourth over 4. Done. Sure, 1/4 x to the fourth. If f of x is 5x to the fourth, then capital F of x is equal to 5x to the fifth over 5, and the 5's cancel, leaving you with x to the fifth. If you have 4x to the sixth, if you have 3 over 2x to the third, well, first I think that we should write that in a better way. How about 3 over 2 times x to the negative third? How about we write it like that first? So now what we should do is increase it by 1 to get 3 over 2 times x to the negative 2 over negative 2. So the 3's on top. Yes. 3 over negative 4x squared. No. Now, what you have to understand is that finding antiderivatives is actually more challenging than finding derivatives. And I'll give you an example here. Let's suppose that you had this, okay? If I had f of x equals e to the x squared, which is actually a very, very, very important function, I could find the derivative of that very, very quickly. If you ask me to find, so f prime of x, easy, okay? F double prime of x, almost impossible. Going the other direction it can be ridiculously difficult, and sometimes they are impossible. We have to use all sorts of other types of mathematics in order to actually do it. Calculus 2 investigates that, but there are times where it is almost generally impossible. Yes. Yeah, so your double antiderivative. Well, you would take the antiderivative of the antiderivative. So you could keep on going. But I want you to understand that what we just did, you guys need to learn how to take antiderivatives. We're going to start easy, but much of the rest of this course, much of it, is about finding antiderivatives, because it is much more challenging than finding a derivative. And you'll get really good at it. And you'll learn techniques that next year in college, other people will be like, wow, your professor or your teacher spent time with you going over that. Good for you. It'll be easier for you. Okay, so let's use this now. Fundamental theorem of calculus, part 2. Given this, the integral from a to b of f of x dx. We said that that was equal to the limit as n goes to infinity of the summation from I equals 1 to n of f of x sub I delta x. Remember? We are going to redefine it so that it's easier. This is equal to f of b minus f of a, where f is any antiderivative of f. And I write any because there are an infinite number of antiderivatives for each function. You might ask, how could that be? We'll get to that later. It's not important right now. Remember when I looked at a function, I told you that the answer was 8/3. Watch how quickly I was able to do that, and you'll now be able to do the same thing. If I want to evaluate the area bounded from 0 to 2 of x squared dx, you don't have to use that anymore. First, we find an antiderivative. What is the antiderivative of x squared? Evaluate it from 2 to 0. That's how I write it. Put a bar, and I put 2 at the top, I put 0 at the bottom. We plug in 2. What's 2 to the third? Over minus, plug in 0. It's that easy. I mean, it's just, remember before you had this 2? Before you had this 2 and you wondered, what should I do with it? And we had to use this. Shh, boys and girls. You had the beginning plus the width times I, and we had to, go through and FOIL that whole piece out and work through it. It's very difficult. Now it's no big deal. What's the antiderivative of 3x squared? X cubed. We'll evaluate it at 4 and 2. What is 4 to the third? What's 2 to the third? Sure. 3x squared. If you want to take the antiderivative, you increase the exponent by 1. Okay? So 3x to the third divided by that 3. The 3's will cancel, leaving you with x to the third. So all we need to do in C is we need to create, a power. Right now, you guys only know how to do this for power functions. We'll change it, not to the -1/2. So this is 3x to the 1/2. So if I want to find an antiderivative, I increase the exponent by 1, which is 3x to the 3/2 over 3/2. So you would have 6 over 3, which is 2x to the 3/2, evaluated at 2 and 1. Well, it's an irrational number. So, I mean, we got to take out our calculator and come up with a decimal. So we take, I'm not done with C. 2 to the parentheses 3 divided by 2. I get 2.83 times that by 2. And I get 5.66. So 5.66 minus, now we'll plug in 1. 1 to the 3 halves is 1 times 2 is 2. 3.66. That's it. No. Oh, nothing. Tomorrow, you have an assignment. Kelly, you see how I got 5.66? I plugged in 2. If you didn't turn your homework in, make sure you turn it in. Kelly, you got it? All right.